what about the direction of the relationship? Well, I've already mentioned that we learn about or can tell the direction of the relationship between our variables by looking at the sign of the R value. Whether the R value is negative or positive, that tells us the direction of the relationship. If you get a positive R value when you do your calculations, it means one of two things, which is basically saying the same thing, and I'll show you with a graph. But anyways, if it's positive, it means that as X increases, Y also increases. But you could flip-flop that around and say as X decreases, Y decreases. In other words, X and Y are moving in the same direction. Either X and Y are both going up, or X and Y are both going down. That is a positive correlation. Okay, you're going to get a positive R value. On the other hand, if you get a negative R value, it means X and Y are moving in opposite directions. So there's two possibilities. You could look at it this way and say, as X increases, Y decreases, or as X decreases, Y increases. All right? It's really saying the same thing. Because remember, if it's positive, it means X and Y are moving in the same direction. If it's negative, it means X and Y are moving in opposite directions. So it doesn't really matter if you say X goes up, Y goes down, or X goes up, Y goes down. They're still moving in opposite directions. It would still be negative. You'll see that here. Okay, so here are some scatter plots to illustrate the direction of a relationship, all right, and what that actually means. So if we look at A, all right, we can see that as we move along the x-axis, what's happening to these numbers? They're going up, right? So as we move along the x-axis, the numbers increase. What is happening to the y values? As x is going up, y values are going down. They're moving in opposite directions. That means that the slope of the line will be negative, and it also means that we have a negative correlation or a negative relationship. As x increases, the y values decrease. Now, if I started at this end instead, then it would sound different, but we're describing the same relationship. This says as x decreases, as x is going down, what's happening to y? Y is going up. But you see, it's the same relationship. It just depends whether you want to start at the left end of the graph and go right, or if you want to start here and go left. But you're describing the same relationship. All right, X and Y are moving in opposite directions. An example might be, let's see, as the number of police cars on the highway increase, your speed decreases. How's that? Okay, so as the number of police patrol cars on the highway increase, the average speed of the cars decrease. Okay? All right, we're going to come back to B. I want to look at C next. Okay, so we'll just save that. This one describes a positive relationship. Why? Because we can see as X increases, Y increases, right? So look at that again. As the values of X increase, what happens to the values of Y? They are also increasing. So this is a positive relationship. It's not perfect because not all points fall on the line. Same thing over here. We said this is a negative relationship. Not all points fall on the line, but we can see a very definitive pattern. Same thing over here. All right. Only this pattern here represents a positive relationship. X and Y are both moving in the same direction. As X increases, Y increases. Or you could say the other way around. You could start over here on the left and say, okay, as X decreases, what happens to Y? Y is also decreasing. Okay? An example of this would be as your rate of speed increases, so as you go from, 50 miles per hour to whatever, 100 miles per hour, etc. So as your speed increases, the price of your ticket, your speeding ticket, also increases. I must be hung up on traffic violations. I swear I have not had a traffic violation in a very long time. But for some reason, those examples are just coming to me. Okay, what about this one? This one is a positive relationship. Why? Because the slope of the line is positive, but also because we can see as X is increasing, so is Y. All right, so as X goes up, Y is going up. We can see that with the dots here. This one is a negative relationship. And that's because X and Y are moving in opposite directions. As X is increasing, what's happening with Y? Y is decreasing. What about this one? Back to a positive relationship. As X increases, Y is also increasing. Okay? So you can tell just by looking at the scatter plot and looking at the direction that the dots are moving in. All right? Are you going to draw the line with a negative slope or a positive slope? That's going to tell you whether your R value will be positive or negative. But these graphs are doing more than that. And don't worry, I'm going to come back over here in a second. These scatter plots, just at a glance, we can tell how strong the relationship is between our two variables, X and Y. Remember that on previous slides we said if all the points fall on the line, that's perfect, represents a perfect relationship. Well, none of these, therefore, are perfect. But can you pick out the one that is closest to being perfect? Hopefully, you have said F. Because if we look at this relationship here, yes, it's true that not all the points are on the line, but they're pretty darn close, right? Which one would have the worst relationship because the points are scattered all over the place, not anywhere close to the line on average? Well, hopefully you're going to point to B and say, okay, I can't even tell if I should be drawing a line that is negative, has a negative slope, or draw a line with a positive slope. All right, I'm kind of confused here. I don't even see any pattern that would support one or the other. In a case like that, the best line you can draw is a flat line, a horizontal line, perpendicular to the x-axis. Just make sure it's a flat line. So this one is not quite flat, but, it's good enough. All right, in a case like this, we would say there is no relationship between X and Y. In fact, if you were to try and calculate the R value, it would be very, very close to 0. Okay? Okay, so this one is the worst in terms of the strength of the relationship. F represents the strongest relationship. What would be next in line to F, though? Next strongest. So it would be E, right? If we're looking, now ignore the slope of the line. You're just looking at the scatter around the line. These points are next in terms of, well, they're pretty close to the line. Not as good as F, but still pretty close. Right? Which one would follow next? I would say this one. All right, D, we are beginning to see a little bit more scatter. It's not as good as E. We're seeing more scatter, so that means the relationship is beginning to weaken. The more scatter you see, the weaker the relationship gets. And then I would say A is next, followed by C. There's even way more scatter here, but of course we have the most scatter with B. Okay? So you should be able to see a quiz question or a question on an exam where I give you a bunch of scatter plots, and you should be able to just look, even without a line being present. Okay? You should be able to look at these scatter plots and say, Okay, that one, there's no relationship. This one over here is very strong and it's positive. This one over here is kind of moderate and it's negative. So you should be able to look at them and describe them much like I've done here. Okay.